Good morning, P7s. I hope you're all keeping well. So it is Monday, the 8th of March, and this week we're going to look at decimals. So today's focus is our understanding of place value. So things that we're going to be looking for are, can you understand what each digit represents? Can you count on and back in decimal number sequences? And can you compare and order decimals? So that's according to size, starting from the largest or starting from the smallest, and so on. So to start today's lesson, we're going to look at some just little revision tasks that I would like you to complete. Okay, so use your jotter, write the questions out. Maybe the first one you might want to use a written calculation method to help you calculate the answer. So if you want to pause the video now before I get through the questions. Okay, so the first question here, so we need to borrow a 10, so 0 take away 1 we cannot do, so we need to borrow. So make this 1, and this becomes 10, so 10 take away 9, or sorry, 1 is 9. 1 take away 3 we can't do, so we have to borrow again. So that becomes 8, and this becomes 11. 11 take away 3 is 9. 8 take away 7 is 1. 3 take away 1 is 2. Okay, so 2,199. Okay, so 2/3 of 15. So if you know your 3 times tables, you will know that 3 times 5 is 15. So 1/3 of 15 is 5. 2/3 is going to be 10. Okay. Okay, the next question. The table shows the temperature at 5 a.m. on 3 days in May. Okay, so 4th of May, you can see it's -6. That's 6 degrees below 0. The 5th of May is 3 degrees. And the 6th of May, it says, work out the difference in temperature on the 4th of May and the temperature on the 5th of May. Okay, so 4th of May is -6, 3 degrees on the 5th of May. So there's 2 different ways you could do this. You could just add 6 plus 3, which is a difference of 9, so the difference is 9 degrees. Or you could use a blank number line and think, right, well, you're going from 0 to you're going from -6 to 0. Now that's going to take you 6 degrees. And then you're going from 0 to 3, and that's going to take you 3 degrees, and you just add the 2 of them up. It doesn't matter what method you use, the answer is 9 degrees a difference, okay? The temperature on the 6th of May was 6 degrees lower than on the 5th of May. Okay, so if you start off with 3 degrees and you're going back 6, okay? So if you were to go back 3 of that 6, you would be at 0. And then you have 3 further degrees to go back, so that would bring you back to -3. So the temperature on the 6th of May is -3 degrees Celsius. Okay, so you may remember this chart from the tasks that we completed based on dividing by 10, dividing by 100, and divided by 1,000, and multiplying by 10, multiplying by 100, and multiplying by 1,000. So it's the same type of chart, and it's to help us understand the value of each digit, okay? So you can see the decimal points in the chart, and anything, and it ranges from millions on the left hand side of the chart to 100,000s on the right hand side of the chart. Now we're not going to be using all of those different values. We're just going to look at smaller numbers today because they're first day of looking at decimals, so we'll start fairly easy. Now anything to the right of the decimal point, they are not whole numbers. So if you look at the tenths, hundredths, thousands, 10,000s, 100,000s, they're less than the number 1, okay? And anything then to the other side of the decimal point, ones, tens, hundreds, thousands, they are obviously whole numbers, okay? So I'm just going to put a few numbers into the chart to hopefully help you understand the place value of each digit and what it represents. So if I start with just a simple number, 3.21. Okay, so this value of this number is worth 3 units, or 3 ones, 2 tenths, and 100ths, okay? So the further I go over to this side of the chart, the smaller the value of the digit is, okay? So the biggest number I have here, the biggest value of the digit is 3, which is worth 3 ones, then 2 tenths, 100ths, okay? So we'll try another number. So say I try 0.19, okay? So there's no units in this number, there's 1/10, and there's 900ths. Now this 1 here, and this is what sometimes gets confusing about decimals, this 1 is worth more than this 9, okay? So that 1 is worth 1/10, and the 9 is worth 900ths. So you can see how decimals can sometimes be confusing, but we're going to do lots and lots of examples, and hopefully you will be able to understand how to order them according to size, know what the value of each digit represents, and so on. Okay, so we're going to start off quite easy. We're going to look at some decimal number sequences, and I'm going to complete the first example for you. So it's 0.92, 0.94, 0.96. So I can see that the value of the hundredths digit is going up by 2. So if you look here, it's went from 2, 4, 6. All the other digits are remaining the same. So this one is going to be 0.98. Okay. Now, if I add another 2 on, or 200ths, my number then, this gets quite tricky, my number then becomes 1.00. Now you can write that down, as I said earlier, 1.00 is exactly the same as 1.0, or just the number 1. But I'm going to leave it at 1.00 because it'll help me then complete the next part of the question. So if it goes up another 200ths, it's going to be 1.02. And then that matches in because the last one is 1.04. So you can see that this 2 here has got 200ths bigger to come up with the answer 1.04. So I want you to complete the other 3 questions now in your jotters. So I want you to pause the video before I get through the answers. Okay, so if we look at this question here, you can see the numbers again are increasing in size. So 1.76, 1.77, 1.78, 1.79. So if you think of this 79 as a 79, then the next number then will be 1.80. Okay, and then 1 greater than 80 is 81, so 1.81. So that's quite an easy example, and it ties in because the last answer is 1.82. Okay, next we have then 2.54, 2.52, 2.50. So you can see, look, the hundredths here is going down by 2, so 4, 2, 0, and you think of 200ths less than 50, so, or just 50 take away 2, so 2.48. Go down another 2, 2.46. Go down another 2, 2.44, and then you can see this is clearly a mistake here. This number should be 2.42. Silly Mr. Donnelly. Okay, so the next one, 3.04, 3.03, 3.02, 3.01. Okay, so it's going down 100th each time. So 3.01, 3.00, and then the last answer can really help you. So the number in between, say if you thought of this as 300 and 298, so the number in between is 299, so 2.99. Okay, so I hope you get on well with those. Okay, so in this slide we're going to really focus on finding out the value of each digit within decimal numbers, okay? So I'm going to complete a few examples for you, and then I want you to try some of these tasks on your own. So if we look through the numbers, if I just read through some of them, so the first blue number there to the left is 30.6, so I know this number has 3 tens, 0 units and 6 tenths, okay? Then the yellow number, 45.8, 4 tens, 5 units and 8 tenths. 3.24, so it has 3 units, 2 tenths, 4 hundredths, 6.38, 6 units, 3 tenths, 8 hundredths, and I'll finish with 1.75, so it is 1 unit, 7 tenths, and 5 hundredths, okay? So I'm able to work out the value of each digit, okay? And you know from earlier that as you move across the number to the right, the value of each digit then decreases in size. So for example, when I start with, say, with 45.8, this 4 represents 4 tenths, that's 40. This 5 is 5 units, that's 5, and 8 tenths. It's a digit that's worth the least because it's only worth 0.8. So it's not even worth 1 unit. Okay, so as I said, I'm going to complete the first few questions for you. So the first one is, which number has 2 tenths? 2 tenths. 2 tenths. So I'm looking tenths. I'm looking for 1 place to the right of the decimal point. So I'm looking for a number that has 2 directly after the decimal point. Okay. So here it is here, 3.24. That number has 2 tenths. So which number has 5 hundredths? And for this one, I'm looking for a number, so it's not that digit, it's going to be here. So 2 places to the right of the decimal point. And here it is here, 1.75. So that is 5 hundredths, that's 7 tenths, 5 hundredths. Okay, so now I would like you to pause the video because I want you to complete the rest of the questions on your own. Okay, so we're on to C. So 7 units, and I'm looking for a number that is 1 place to the left of the decimal point. Okay, so there might be something here, there may not be. So 7 units, and I can see it's 97.4. Okay, so 9 tenths, 7 units, and 4 tenths. A number with 4 tenths. Okay, 45.8 here. It has 4 tenths, okay? The largest 10th digit, so as I said earlier on, the 10th digit is the one directly to the right of the decimal point. It's the largest 10th digit, and that is 13.9 because you have 9 tenths. The smallest 10th digit, that is 8.07 because you've got 0 here. A unit's digit double the 10th digit, okay? So the units digit I'm looking for is going to be the left of the decimal point. It's going to be here. And it's double the 10th digit, so I'm looking for a number here that's going to be double the size of the number there. Okay, I'm not too sure about you, but it took me quite a long time to find that one and really think about it. So it is 6.38, so you can see the units digit is 6 and the 10th digit is 3, so 6 is double 3. And the next one, a hundredths digit that is half of the 10th digit. So again, that was quite a tricky question. A hundredths digit, half the 10th digit. So it's down here, it's 2.63. Because this is 3 hundredths, that's 6 tenths, and 3 is half of 6. So again, we're going to focus on more place values, so finding the value of each digit, but we're also going to look at identifying the largest and smallest numbers within some selections of decimal numbers. So if we look at A to F here in the first series of questions, it says what is the value of each red digit, okay? So if I look at the first one, so this is 7 units, 1 tenth, and 6 hundredths. So what is the value of that red digit? That value is 0.1, okay, or 1 tenth. The next one, 16.9, so that's 6 units. Okay, so you have 1 tenth, 6 units, and 7 tenths, so that's worth 6. C, 1.67, so that's 1 unit, 6 tenths, and 7 hundredths, so it's worth 0.07. Okay, so I'd like you to pause the video now because I would like you to complete D to F on your own. Okay, so I hope you're able to complete those tasks. So the first one, D, 43.8, that 4 is worth 40. So it's worth 4 tenths or 40. 6.92, so 6 units, 9 tenths, 2 hundredths. So it is worth 0.02. Okay, 5.05. Well, this 0 is worth no tenths. Okay, and if you're writing it down as a number, it would be worth 0.0. Okay, but it isn't worth anything. Which is the largest number? Okay, so I'm going to complete question A for you, and then I would like you to complete B and C on your own. So this is where sometimes it can get quite tricky. So 2.48, 2.84 and 2.80, so they all have 2 units. So we're looking for the one then that has the most tenths then. The one that has the most tenths, well, these two both have the same, they both have 2.8, but you can see this number here has 4 hundredths. This one doesn't have anything, so this is the largest number. This would be second, and this one here would be the smallest out of the 3. Okay, so pause the video now, and I would like you to complete B and C. Okay, so if we look at B, sometimes it's easier to convert these numbers. Okay, so you have 6.76, and you know that 76 is bigger than 75. But what does the 7 represent? Well, the 6.7 is exactly the same as 6.70. Okay, 6.70. So first is that's the largest, 6.76. This would be next, 6.75, and this would be the smallest. Okay, for C, well, you need to look carefully at the units here. Okay, it's 2.31. Even though the tenths and hundredths are bigger than the other two numbers here, because that's 12 and 21, the units is smaller. So this here is our largest number, 3.21. Next would be 3.12, and the smallest number would be 2.31. Okay, I'm going to complete now A, for which one is the smallest number. So this is 51, that's 15, and I can convert this. I'm going to change that to 6.50, okay, because they all have the same amount of units. So which one is the smallest number? Well, the smallest number, 15, is smaller than 50 and 51, so that is the smallest. Next would be 6.50, and then that's the largest number there. Okay, so I'd like you to pause the video because I want you to complete B and C now on your own. Okay, so for B, I'm just going to use the same process as I did the last time. So I'm going to add a 0 on the 8.7, so the number is exactly the same. So they all have the same amount of units. The smallest number then is 8.57. Okay, next smallest is 8.70, and 8.75 is the biggest. For the last one, I'm going to do the same thing. So I'm going to add a 0 there, 4.30. So your smallest number is the first one. They all have the same amount of units, so that's your smallest. Next is 4.35, and then the largest number is the last one, 4.53. Okay, so this slide is focusing on writing numbers in order, starting with the smallest. Okay, so it's really important you read the questions properly. So if I get through the first example for you, so it's 0.44, 0.4, 0.89, and 0.5. Okay, so if I convert all of these here, so if I put 0.4 and convert that to 0.40, same thing, then 0.50, it makes it easier for me to actually compare and order the numbers. So I'm just looking for the biggest number now, so 0 point after the decimal point, so that will be 89. So the smallest number then would be here, the 40, so in order 0.4, so use that one, then 0.44, use this one, then 0.5, I've used this one, and finally 0.89. Okay, so I would like you now to complete questions 2, 3 and 4 on your own, so pause the video now. Okay, so the smallest number in this example here is 0.09 because it doesn't have any tenths. Now I deliberately put a 9 in there to try and see if I could confuse you. The next one then is 0.19 because it only has 1/10. And then the next number is 0.2 and finally 0.7. Okay, so smallest number in the next sequence. So I'm looking along the units here. This one is 5 units, 1 unit, 2 unit, and 5 units. So smallest one is the one that has only 1 unit. and that is 1.99. Then this number here has 2 units, so it's 2.29. Then 5.01, because it has less, it doesn't have any tenths, and the last number has 3 tenths. Okay, so this is quite a tricky one, the last one. But if I look at 0.99, it doesn't have any units, so it is the smallest. Then the next smallest is 9.09, because it doesn't have any tenths. 9.19, and then the greatest then is 9.99. So this task is very similar to the task on the previous slide, apart from we are ordering the numbers, this time starting with the largest. So again, I'm going to complete the first example for you. So if you look at these numbers, 0.88, 0.9, 0.89 and 1.01, this is the only number that actually has a unit, so it is the largest, 1.01, okay? Now, this 0.9, it represents, you could write it down as 0.90, okay? So 90 is bigger than 88 and bigger than 89, so it's 0.9. Then it's 0.89, and then finally 0.88 is the smallest, okay? So I would like you to pause the video now, and before I get through questions 2, 3 and 4. Okay, so starting with the largest, so again this 0.9 represents 0.90, so it is the largest. Next then is 0.77, then 0.19, and finally 0.09. Okay, number 3, so starting with the largest, 5.2. I know, sir, I've written 5.03 down twice, so it's 5.03 and then 1.89, so you can forget about that second one there. Okay, now I'll be able to know who watched the video and who didn't. So the largest number here is, in this bottom example, is 9.32. Then it is 9.09. Then 1.09. And then finally the smallest number then is 0.91. Okay, so this is a little challenge I would like you to try and complete this week, and again you've got a whole week to try and complete it. It would be great to see some children posting their answers. You can just post a photograph of your answer on Teams. So what you have to do is you'll have to draw the grid out, and can you put the numbers 1 to 7 in each circle, so the total of every line is 12. So you've got 7 numbers to go into the grid, 1 to 7. You can only use each number once, and each line has to add up to a total of 12. So if you think it has to be 12 going across here, this line, 12 going in this line diagonally, same with here, and going across here horizontally. Okay, so it is quite tricky, but I think you'll enjoy the challenge. Okay, good luck with that.